Hello, my name is Brian Dean with PowerFlex Technical Marketing. Today I'm going to show you a demonstration of PowerFlex's amazing resiliency. PowerFlex is Dell Technologies' software-defined block storage platform, and it's well known for its unmatched scalability and performance. I call this demonstration "Bend but do not break." This saying represents an idea that's been illustrated in ancient Greek fables, Chinese proverbs, and even defensive strategies in American football. The main idea is that a thing which can bend in the middle of a powerful storm, like a reed or palm or willow tree, will survive when a rigid tree like an oak will break. Being flexible is better than just being strong when disaster and difficulty strikes. The ability to bounce back, to be resilient, is what's most important. PowerFlex can deliver millions of IOPS while scaling to hundreds or thousands of nodes, and it does so at microsecond latency. And as we've pointed out in some recent blogs, the same architecture design that enables that scalability and performance is also what makes it so resilient to hardware failures and the unexpected. Just as PowerFlex's performance increases linearly with the addition of node and drive resources, the system's resiliency increases in the same way. The demonstration we're going to watch shows what happens when a drive fails, how quickly PowerFlex detects the failure and begins to fix things, and how very fast it does the fixing. As we watch the demo, I'll explain what's going on behind the scenes. What we have here is a middle-sized 12-node PowerFlex cluster with 6 SSD drives in each node, and we're letting it ramp up with some workload as we get ready to see a drive fail. One key architecture point about PowerFlex is that a volume's data is distributed over every single disk that is contributing to a storage pool on all the nodes that contribute. And we automatically balance that data around when capacity changes if we add drives or nodes. This results in no hotspots, and we'll see that on disk or node failures we get an automatic rebuild. We do this massively parallel distributed mesh mirroring of data to keep 2 copies of it on different parts of the system at all times. And the performance and the resiliency increase linearly as we keep adding resources to the system. Superior data protection really comes from superior software-defined architecture. As we're watching the performance monitoring in the main PowerFlex dashboard, notice the health indicators in the upper left. At this point in the timeline, we're going to intentionally fail a drive. Notice that it takes about 7 seconds for PowerFlex to see the issue, diagnose it, remap the needed data layout, and start the rebuild job. In the health indicators in the upper left, you'll see the system shows as degraded. This is because the data mirror copies that existed on the drive that failed need to be rebuilt elsewhere in the system to have full redundancy back. In the lower right portion of the dashboard, you can see that we have over 400 gigabytes of data to be rebuilt. When a system is under load and there's lots of I/O, PowerFlex demonstrates that principle of bend but do not break. As the cluster is remapping the data placement and reprotecting the copies, there's a brief drop in IOPS, but notice that the latency never drifts above 600 microseconds. Once the rebuild process is underway, and more of the mirror copies are restored to redundancy, the performance of the PowerFlex system quickly rebounds to its pre-event levels. At this point, you can see that there is no more data to be rebuilt. The cluster is no longer degraded, and although we still have a failed drive in the system, it's perfectly healthy. Unlike RAID and other schemes, the failed drive does not need to be replaced for the system to be healthy. PowerFlex's protection scheme focuses on the data, not the drive. This whole process is blazing fast, taking just over a minute. In fact, we're usually finished restoring full data protection before most systems even detect the failure. Priority goes to reprotecting data. Once that is finished, the system will start rebalancing the data on the remaining nodes and drives, ensuring even placement and usage by all components of the system. Because this rebalancing process is not fixing a health issue, it runs at a lower priority by default. However, PowerFlex administrators can tune both the rebuild and the rebalance priorities, giving preference to application I/O or the data redistribution processes as desired. Earlier, we noted that the resiliency and the speed at which PowerFlex can reprotect data increases with the addition of more nodes and drives. This chart shows the near linear improvement in time required for rebuilds, depending on the data footprint in the system and the number of nodes making it up. And the story is the same when it comes to full node failures. There's a greater amount of data to be reprotected, but the process is the same and it gets faster and faster as the system grows. Thank you for watching. We hope that you'll contact your Dell Technology sales team and discover the unique superpowers of PowerFlex software-defined storage for yourself.